If I have, this can also be used not only to find those OR probabilities, but you can also use it to find other probabilities if you know the other three. So on our, just rewrite the formula here. Yeah, so the ones we worked out so far, we've had these three, right? Or we were able to come up with those those three amounts. However, if we know there's four things here, and so if we know three of those four, we can figure out the fourth one. It doesn't have to necessarily be that we are finding probability of A or B. We can find any of those three if we if we've got the other three. So here's an example of what I'm talking about. All right, so let's say if the probability of A is 0.25, probability of A and B is 0.1, and the probability of A or B is 0.65. Right here. Find the probability of B. Okay, so yeah, this formula can be used here because here's what I've got. I've got the probability of A, I've got the probability of A and B, and I've got the probability of A or B. And so, yeah, I've got three. I can find the fourth one. Just plug in. You don't have to necessarily know a different formula. Just plug these in and then do a little bit of solving, I guess. Yeah, so A or B, we've got 0.65. Probability of A, that's going to be 0.25. Probability of B, that's what we're seeking here. And then probability of A and B, yeah, so that's going to be minus 0.1. Is everybody all right there? So just plug those respective probabilities that I'm given in, and then, like I said, just do a little bit of solving. In this particular case, do it however you want, but as long as it's correct. But on this side, I've got 0.25 minus 0.1, so I could combine those if I wanted to. I could go ahead and just subtract that and add that, however you like. So let's just do it that way. All right, so we can subtract the 0.25 and add the 0.1. Right? That would, because basically what I need to solve this is I need this on its side by itself. So subtract the 0.25, gets rid of it there. Add the 0.1, gets rid of it there. And so now just have to compute that. What that would be, was that 0.5? So if I do 0.65 minus 0.25 plus 0.1, is that 0.5?
Yeah.
0.5. So probability of B is 0.5. Is that all right? Is that okay? All right, now, another term, there's another term here that we can talk about. Let's go back to the card problem. Let's say I've got, drawing the card again. Draw a card from a standard deck. What is probability? We draw a heart or a black card. Yeah, this is kind of a special. I mean, we can treat it just like we have been. Probability of heart or black is, so it's probability of heart plus probability of black minus probability that it's both heart and black at the same time. But what we see here, all right, so heart's one of the suits. There's 13 hearts in the deck out of 52. Black, those are spades and clubs. So 2 suits are black, so there's 13 13 spades, 13 clubs. There's 26 black cards. But what about this? How many of them are both heart and black at the same time? Can you have a heart with a black? No. You can't have that happen. So that's 0 out of 52 here. Well, at 0 out of 52, that's 0. Essentially, this part here is nothing, or it is nothing. You're just adding the hearts plus the blacks probability. 39 out of 52, which is actually does reduce, that reduces by 13 to 3/4, 4.75. Anyway, this is an example of what are called mutually exclusive events. Drawing a heart, drawing a black card, those are what are called mutually exclusive. Cannot happen at the same time. So that's called mutually exclusive. So those are events that cannot occur at the same time. And one other note is that if you have mutually exclusive events, the probability that it's both at the same time, like we said, they can't occur at the same time. So the probability of that is 0. And so anytime you have mutually exclusive event, this part will be 0. And so what that tells me is when I'd have, if A and B are mutually exclusive, A and B are mutually exclusive, then the probability of A or B just equals the probability of A plus probability of B. You could put the probability of A and B on there, but it's 0 if they're mutually exclusive, right? If they cannot occur at the same time, that's all that means. So, if you see something about that, that's all that means. They can't occur at the same time, mutually exclusive. All right? Any thoughts or concerns there? I mean, it works out even if you use the other formula, but that one you don't have to subtract anything because it's 0 that you're subtracting anyway. So. Any questions? All right.